Hello friend, welcome. In the last video, we implemented the factorial and greatest common divisor GCD using if, else, if then else, right? Which is called conditional expression. Today, we'll use a different way to implement the factorial and the GCD. It's called guardian equation. Guarded, right? Guarded equations. Okay, and yeah, before that, let me show you a trick to clean up the screen of terminal. For example, we have like calendar here. Today is November 20th, 2020. Wow, 20. Oh, that's interesting. So we can use clear, right, to clear that. And a shortcut key for that is Control L. Why did I mention that? Because this trick also works in GHCI. You see? Right? Control L. You see? Cool, right? Let's go out. Okay, Control L. Yeah. Now let's go inside GHCI. This is the standard prelude. That's the default library provided by GHCI with a lot of built-in functions. So last time, let's review the implementation we did last time, right? For factorial f, that's the name. Okay, I'll keep it simple and short. Factorial n, right, equals if n is, last time we used 1, right? This time let's use 0. So we can include one more number, right, in the domain of our factorial function. Okay, so if that, then we just return n, right? Else n times factorial of m minus 1. That's it. So f3 is 6, right? What? Fn equals, if, oh, sorry about that. This one is 1, right? Because by definition, 0 factorial, right, is 1. It's not 0. Let's do it again. 3, yeah, f5 and f1 is 1, f0 is 1. Yeah, that's the cool thing for us, changing this to from n equal 1 to n equal 0. Okay, so now, oh, another one, the GCD, right? GCD, let's use G for that. So G mn equals if, based on our based on Euclidean algorithm, is if n is 0, we returns, then is just m, right? Else is g of m mod n, right? That's it. Sorry about that. What's wrong? Oh, we need 2 numbers here. This is just 1. So it's n and that. No, it's like that, right? G of this is the first argument. This is the second argument. Now it should work. Oh, gmn, if n is that, then m else do I need the parentheses here? Control E to go to the end. Okay, Control A to go to the beginning of the line. Okay, so oh, now I'm in trouble. So GMN equals, if n is that, then m. Oh my god, this is my memory from other programming language. Actually is this guy should be like that, mod. Okay, or we can use like mod m n, or we can use m mod tilde, right, n. Okay, so it's fun. Yeah, so we need more practice for that. So this one we can use mod m and like that, so we don't need this guy. Now it should work. Okay, G 24 and 15 3. Okay, so now we have f function, right, factorial, and G. What about the 16 and the 24? It should be 8, right? Yes. Finally, we can try a different way. It's called guarded equations to do that factorial thing. Okay, let's redefine it. So it's like that. F n such that a vertical bar such that if n is 0, then equals the value is equal to 1. Okay, we need the second line, so it doesn't work. So there's two ways to input like multiple line code inside the GHCI. If it's not inside the GHCI, it's like in a script, like a text file, right? We don't need that, the following. But now we need because this is not funny, we need multiple line for that. So one way to do that is using something like that, colon opening brace. Okay, you see? Now here is our, we have to use, yeah, this is another thing we have to use, let. So if it's not inside the GHCI, it's in the script file, we don't need this let. But now for the multiple line code, we need that let fn such that if n is equal to 0, then the value equals to 1. Now you see, this is not the same as that one, right? This is the multiple line, so we need to line up this one here such that, and if n, oh, else, otherwise it's else, right? Otherwise equals to n times f n minus 1. Oh, now it's finished, so we need to close it, right? So colon closing curly brace. Now it's done. So f, right, 5, yeah, it works. So another way to do that is, so this, yeah, let's use this, let's do it again for our GCD, okay, G. So opening curly brace, right? Now let's do that, G of mn such that if n is 0, then the value is m. Otherwise, such that otherwise equals to G of n and mod m n, right? The remainder of m divided by n. Now it's done, so we can close it, colon, closing brace. Now g, let's try it, 4 and 6 will be 2, right? So g of prime numbers 1. Okay, so again, we only need these things and that in JGCI to write multiple line code. Otherwise, if it's outside JGCI in a script file, we don't need that. We can only need this part here. But important, this has to be lined up because indentation is how Haskell groups the code. Okay. Now, what's the other way to do that? We can set. Other way to accept the multiple line is we can set plus multiple line like that. Now we don't need this. Let's try it again, but we still need let. Okay, so let's try let fn factorial n such that n equals 0. The value is 1. You see, enter, right? We still need to line up there. Otherwise it's actually an alias of true. It means true. So this one equals n times factorial of n minus 1. Same thing. Enter. Enter again. You see? F4. What is F4? Is it 24? Yeah, it should be 24. Okay, cool, right? And let's do it for the GCD. Okay, so it's like let, because this one after it's set, okay, but next time when we come in again, it's gone. We need to set it again. So let me show you. So let's quit and come in again. So I forgot to show you to like control L thing. Control L. Yeah, cool, right? So if we do let gmn such that if n is 0, then equals m, then enter. No, it doesn't work. It failed to go into the multiple line mode, so we need to set it again. Set add multiple line. Now we can do this. Enter. Okay, line up here such that otherwise. Can we use true here? Yeah, maybe. I think so. Let's try it. Otherwise, it's same as alias of true, the logical value. So, what is the else? Otherwise, is equal. Equal to g of n and mod m n like that. Enter. Enter. Yeah, g. Let's try 5 and 10. Should be 5. Yes, it works. Okay, so otherwise it's same as true. Yeah, it's just a syntax sugar. Okay, remember, I prefer to use to replace the prompt, right, using my favorite lambda letter. So that's what I did. Set prompt to this lambda, guys, and that, right? So now can I do let's do this again. Let, okay, enter. Oh, this is not good. You see, I prefer lambda bar instead of that because now this one is not consistent with this one and actually is too long. So how can we do that? We need to set another thing. Set prompt continuity to something like this one. Oh, where is it? Yeah, now bar space. Okay, this time let's do it again. Right, let that, you see, boom, very good, right? And we can still use the history. Otherwise, that, yeah. Now g of 7 and what? And 1? Yeah, it's still 1. Okay, so now every time I need to set 3 things. 1, and yeah, we need to set 3 things, right? This one and that one, right? Prompt for continuity means multiple line code and multiple line. So programmers are lazy guys, so we don't want to do it every time when we enter GHCI. There's one way to do that. We can put those things in the configuration file of GCSI. Let's go out to see. So ls, that's, yeah, cd will go, yeah, cd enter will go to my home directory. So here is not my home directory. My home directory is here. So there's 2 ways to go back to cd. Just cd enter, we can go to my home directory here. Or another way to do that is cd tilde. No, this is, oh, this is tilde. No, the thing above the tilde. This, yeah, the thing above the tilde. So this is for our home directory. That's right. Yeah, now pwd, you see? Yeah. So there's a file called ls. There is a file called .ghc. What is that? There's no the configuration file. Do we have that? Let's see. Yeah, so we'll create one there. It's called ghci.conf. Okay, so that's create one there. This is our home directory and .ghci, and the name is ghci.conf. Okay, yeah, it's empty. So let's put the things we need there, right? Set prompt like lambda colon space and set prompt, also p prompt cont, right? Continuity to lambda again, and this one bar space like that, and we need to set we need multiple lines. Okay, that's it. Escape, save. Now let's go back to GHCI again. Let's see, try it again. This one, enter. Yeah, it works. Yeah, right, it works. So let's try a G like 9 and 6. It should be 3, right? Yes. Okay. So in this video, we played with the actually the guard thing, right? Multiple line, the guarded equation. So again, so this is the function name g and the two arguments. So here is one condition, here is otherwise. Okay, so we can put other conditions above this, the final, the bottom line, otherwise. But we only have one here, so it's like if n is 1, the value of the function is m. Otherwise is right a recursive call to itself with n here and the modulo m modulo n as the second argument. Okay, thank you for watching. See you next time. And another trick here is Control L to clean up the screen. Yeah, and quit. Control L again, keep it clean. Okay, bye bye.